Hi everybody, we got a new project. This is the sun. It's a sun project. We have a sunset and sunrise. Okay, so the way it works, we have the information on the LCD display, and we have an LED. This LED, it's a PWM, and what it does, as the sun rises, the LED become brighter and brighter till it gets to perpendicular 90 degrees, which is right above your head, and that will be the brightest. And then as the sun moves towards the sunset, the LED will slowly dim till it go to zero. Obviously, you can see the LED now. It's on PWM-85. And it has a cycle from 0 to 255. Okay, so this is the sun altitude, which is 22.2. It's on my south hemisphere now. When it starts to get minus, means that it's on the other side of the equator, and if it's on my side of the equator, then it's plus, or it's 22. I don't need to put plus. Then we have the moon azimuth, okay, which is 232.2 degree, and the altitude is minus 5.3. Okay, so, and the moon distance at the moment is 402,000 kilometers. 420,000 kilometers, somewhere there. And then the date, obviously, is the 5th or the 14th. Then back again, sunrise. In my side, the sunrise has my altitude. On my altitude, the sunrise is, sorry, not altitude. My longitude and latitude, the sunrise is 7:31 in the morning, and sunset is 17:54 in the evening. This is what will make the LED dimming. Okay, so, and that's why we'll calculate from the sun altitude, which is positive. Now it's on my side, and the PW, it's 85. All right, so let's see. Okay, this is the connection. It's an LED has a short leg connected to a resistor. Its home, it's 220 or 330 home, just enough for the LED. The long leg is connected to pin number 3, okay, in this case. And pin number 4, it's connected to the button. You press the button, okay, to flip the page on the LCD. And the LCD is I²C, obviously, so it will have pin number 1, it's SEL, and pin number 2, in this case, it's SDA. Right, and then I did a railing here, positive VCC and ground. Okay, so you can see I've grounded it and grounded in VCC on the railing. Okay, and the resistor, it's grounded to the negative of the LED, and the positive of the LED goes to the pin, the GPI or pin number. Okay, now let's see the codes. Okay, I made a secret file with my particular, and this is a type of secret file you can make here. On the secret file, you will have to put your SSID here, your password here. You will have to put the string, or so you have to put the API key here, and your latitude and the longitude here. Okay, so, which I did it in this one, but obviously I don't want to publish my information. So here, what you do, I add this include secrets.h, okay? This is secret 1 because it's a test file for you to see the code, but you can rename it secrets. And what we do here, we have, I double quote this one, but you can unquote them if you don't use the secret file. And what you should do, you should double quote this one, okay? When I mean double quote, you go ta-ta. So it stays there, but it won't read it while you upload your program. And if you want, you can unquote this one if you want to use your network and your password, your network name. And here you can unquote the API key and add it here, okay? Add the key here. Your latitude and longitude, you can add it here. All right. So what I did, and you can unquote all of them. But in my case, because I've got the secret file, it's quoted like that. Okay. So you can, it's up to you. You can unquote all this one. You can unquote your API key. You can unquote your latitude and your longitude. Okay, so instead of put it on your secret file here, okay, you got to put it here. Simple as that. All right, so, and as I said, you double quote this one, so you don't have to worry about this. So what I'll do on the system, I will leave it there, and I will also make a copy of the secret.h. Okay, so what we have here, we have the usual library. What it does actually, the Arduino JSON, I just want to show you that is parsing this information coming here now. So, and it brings it forward here. See, you have here, you have the moon as the moon, the moon AZ, have moon altitude, the moon distance, and you have the sun altitude, the date string, the date, and the sunset will be sunrise, sunset and sunrise, sunset and sunset. Okay. Sorry, sunrise, sunrise, sunset, sunset. Okay, so one is the one that you write in to be typed as a text. The other one is the value that comes from this. This is picked up by the URL, the URL that we put over here, if you recall it. That's a URL, okay? And the URL, it's the IP geolocation, and the API will have all the information that Arduino JSON will parse to put them here, and with the value to publish on your LCD. So you will have on the LCD, you will have, for example, in this case, you have LCD set the cursor to 0, because as I said, it's the first row of 16 block, and 0, 1 is the second row of 16 block. Okay, let me show you. The first row, 16 block here, you can see the block. It's 1, 2, 3, up to 16. So this is the cursor position is 0, 0, and this one will be 0, 1. Okay. Now back to the code. So what we do here, it's parsing. It will parse your location. In this case, it's my location, and it will parse my longitude, and then will bring forward the date, which you can see the date on the screen on LCD. I didn't put the time, but you can put the time as well. the sunrise 7:31, sunset. Okay, every day is never the same. The days are slightly longer or shorter. The lengths, I didn't put the length of the day, 10 hours and 23 minutes, depends, when the sunlight. So I have the altitude here, I have the sun distance. I don't need the sun distance. The sun azimuth, I don't need the sun altitude. And the moon rise, I also put when the moon rise, but I'm not doing the moon here, I'm doing mainly the sun, although I have some information for the moon to give you an idea. Okay, so this is all the information that is passed by the Arduino, and you can change it, you can add and okay, so what we do here, okay, we type moon azimuth, okay, this is my typing, and the moon as is the value that is picked up by this, but the value that is picked up here, okay, has been passed by Arduino. Cursor goes on 01, which is the bottom, and this is alt, which is text that I put there, and this is the moon alt, which is the altitude, which is picked up by the Arduino JSON parsed it, and this information, it's also here. It's all part of this information, and you can pick up certain information like sun altitude. Here it's the amount of obviously you don't want all these digit, so here you put 1 digit or you put 2 digit. If you put 2, will show 2 digit. You put 1, it will show the first digit. Okay. So, but actually I'm not here to explain the code, but yeah. So what I did, I did 4 cases: case 0, case 1, case 2, case 3. Okay. Yeah. I wonder if this is correct. Yeah, should be, because it is there. So let's see how many. So we have the moon azimuth, which is 231. It updates when you press the button. It doesn't update unless you press the button. Okay, so the sunrise 7:31, sunset 17:54, and you can see now the LED PWM it's 90. It means that it's as the sun moves towards 12 o'clock, which is going to be the brightest, and then it's become dimmer and dimmer as you get closer to the the negative altitude. All right. So the moon is the moon azimuth is 230.4 and altitude is -7.2. All right. The moon distance now it's 402,561, and the date is the 5th. I didn't put the time, obviously. Don't need it. Sunrise it's 7:31 and sunset 7:54. This change as well, because all this information is picked up from the API data. Okay, so I've covered everything. This is what it looked like. All right, so sorry, I think I covered everything. Okay. Remember this, to include the secrets if you have the secrets. Okay. In this case it's secrets 1, so you just add 1 here if you want to use this. But I will put it there for you if you want it. It's up to you. Okay, so this will have it's just set like that. All right. And Obviously, I'm sure you're going to use this one to allocate to your place, but if you use a different one, you might have to change few string and constant. Okay, so we have the button pin is D4 and the LED pin is D3. What we got here, I just want to show you here. This is all the parsing of moon altitude, moon this. It's quite a work, I must say. All right, let me. Okay, here. This is the PW brightness. How it happens? It starts from 0. Okay, based on the altitude. Obviously, the altitude of the sun will be based and calculated 90, 30, and 255. Okay, so and it will start from 0 and then will sunrise. Get to 12 o'clock is the brightest one, and after that recycle a loop. Start from 30 down to, 90, well, from 255 all the way back down to altitude when it's becoming more negative, and the LED is becoming dimmer as we move forward the sunset. Okay, sorry, my language is a bit confusing. All right, I think I covered everything. Back to this one more time. All right, sun altitude is 24.4. LED PWM, it's 90, but if I press a button, it's still 90. Eventually, when you change, it won't change here unless you press the button. Moon azimuth, it's 2 to 29.9, altitude -7.7. Moon distance 42555, 425,000 kilometers. Date, it's the 5th of the 14th. Sunrise 7:31, which is already done. A sunset 17:54. Sun altitude is 25. Okay, it's positive at the moment, and LED PWM is 90. All right, I think we cover everything, guys. Thank you very much. Hope you like. If you like, give me a thumbs up. Thank you. Bye.